So what I'm gonna do is I'm gonna show you this one here using definition alternative derivative. It's actually pretty easy. Just limits x approach to 6, I believe, and that's gonna be x minus 6 to the 2/3 minus plug in 6 is 0 over x minus 6. So this is to the first power, so that's gonna be limit x approaches 6. That's gonna be 1 over x minus 6 to the 1/3. And if you approach 6, w does not exist. So therefore it does not exist, because if you graph this one at 6, it's gonna form something called a cusp. A cusp is you have even over odd power. So if you have even over odd power, it's gonna be a sharp turn and vertical tangent at the same time. So it's gonna be a cusp. It's kind of like you draw in the heart, like you draw in the heart of somebody like this, right? And then the top part is a cusp. Actually, matter of fact, I did that with one of the equation here. You see that cusp on the top, the extra 2/3, the top where it forms like this. That's called cusp. It's even over odd power. Yes.
So if like the other questions are also even over odd, would it also be doesn't exist, or is it just for this scenario?
It will be does not exist at that particular point at 6. It will exist on all other point, just not at 6, because 6 is where the cusp is forming. It's gonna form something like this.
Does that mean like for 72, if it's odd over odd, would that be?
That's actually not a cup, but that's actually vertical tangent. You're still gonna reach does not exist on the bottom. It's gonna be a number over 0 that still does not exist, but that situation is called vertical tangent. This case is a vertical tangent and it's a sharp turn. Well, they both are like sharp turn, but yeah. Okay, so can we go to today's stuff? Today's stuff is kind of important. It's power rule. And the most important thing in calculus start right here. The actual calculus start right here. It thinks at first few days it's going to be really easy, and they will get a lot harder. Okay. That's only like a $2 pen, $200 pen. $129, I think. Oh yeah.
Yeah, like the second you know it's like an Apple thing, it's like, oh, okay, yeah, that makes sense.
Yeah. So for me, like, what is a constant multiple rule? So what's derivative of c?
Just 0.
Why is 0?
Well, because you're taking the derivative of the second. It's just.
But why is that 0? You didn't explain to me why is that 0. Yes, Ethan.
It's because it's a constant, and like so, like I'm thinking of the power rule. That means it's times x to the 0. So you would multiply by 0. So you would have 0 times c.
Yeah, but we don't know power rule yet.
Okay.
Yes.
The slope isn't changing.
Which slope? What are you talking about?
The slope on the graph is since you're doing the derivative.
What does graph look like?
Well, I was gonna say like since it's a constant, it's gonna be a linear graph.
No, it's not a linear. It is a linear, but it's not the way you draw it.
There's no slope.
There you go. Chase is thinking. Chase says it's just horizontal line.
Yeah.
It's not the linear, it's diagonal line. It's linear, it's like this. Let's say y equal to 3, and that 3 is a constant. If I take a derivative of this, that's gonna give you a slope of. So taking derivative of something is actually looking at the slope of something. And look at the slope of a line that's horizontal, the slope is going to be 0. Also, a lot of people don't understand this. What is this notation? This means a delta. D stands for delta. delta x, delta y over delta x. That's how much it's changing y and how much changing x at the same time. So this is a derivative of a y, but if I take a derivative, something is d to the dx. So for example, d to the dx of a c is always equal to 0 because I take a derivative of a something that, so how much changing in c? There's no changing in c, right? C did not go higher. So delta c over delta x is, there is no c changes, but there's x change. So therefore it's 0. That's also another way to look at it. It's called constant multiple rule. Now I'm going to take a derivative of something else. Let's take a derivative of something called power rule, x to the n. So this is called power rule. Power rule is super easy. If you take a derivative of power rule, it's going to be take the n here that is in the front and go into here. And then take this power, subtract by 1. So the power is going to be like this. It's going to be n. It's going to be nx to the n minus 1. N that's in the front. So this n is going to drop in the front. So I'm going to show you what happened. This n is going to drop to the front, becomes n here, right? And this power here becomes subtract by 1. And that's the only thing you had to do. Now, next thing you had to do is this. Also understanding something, that the x has to be on numerator. And this is a very, very important idea because a lot of people try to take a derivative 1 over x squared and think that's still going to work, that's still going to hold true. No, it's not. 1 over x squared is going to have to change to become numerator before you take a derivative.
So would that be x to the -2?
Right, using the negative exponent rules. So that's what we're going to get to next. So, for example, we're going to take a derivative of x to the 4th. That should be pretty easy. We're going to take a derivative of cube root of x. That should be pretty easy as well. And we are taking derivative of 1 over x. And that should be pretty easy as well. Lastly, I'm going to take a derivative of 1 over square root x to the 3rd. So let's just say if I want to take a derivative of x to the 4. Catherine, what do you think?
4x cubed?
Yep, super easy. Cake. Well, the second one doesn't have a rational exponents. Can I do anything about that first? Jack, what do you think? Good. So I'm going to rewrite this. Do you realize I'm still have d to the dx in the front? And I'm still just change this using a basic math skill, so be 1 over 3rd. How do you do that? M over n equal to n roots of a to the m. Now this is 1 power, so therefore d to the dx of x to the 1/3. Now I can take a derivative. It'll be 1/3 x to the -2/3. Sometimes I'm not finished with this one yet. I'm going to say 1 over 3. And this is x to the 2/3. Do you realize I just moved to the bottom? Madeline, am I doing okay? Am I going too fast? Ask question if you are lost. It's okay. There's no. And then I can change back to this. And that's my result of a derivative. I'm just using this definition radical. Now I'm going to take a derivative of this. Can I take a derivative of 1 over x? No. What do you do first?
X to x.
Elaine? Good? Understanding? Madeline? Min? Now I'm going to take a derivative. -1 x to the -2. And therefore I'm done. Is anything crazy? No. Can I take a derivative here? No. Can I rewrite this? X to the which power? Not really, no. No. So let's start one step at a time. A lot of you guys is gonna be like, this is 1, this is 3/2, because there's invisible 2 here. Do you see that invisible 2 here? The square root, so that's 3/2. And I'm gonna take a d to the dx of x to the -3/2 because I need to move to the numerator before I take a derivative. So this one is actually -3/2 x to the what? -5/2, right? -3/2, now I change to the bottom. And that's -3/2 square root of x to the 5. And that should be an answer right there. Sure. All right, next. We're going to talk about constant multiple rule. This rule is very underrated, but it's very, very important. Let's say d to the dx of a constant. This is a constant here, f of x here. This constant can take outside like this to become c of d to the dx of f of x. So now I just have to take a derivative of the f of x, which is, if I take a derivative of f of x, that becomes f prime of x. That's just a notation difference. If I take a derivative of x, the f of x becomes f prime of x. Prime is the first time you see that notation with a prime. That means also dy dx. So f prime of x, that's equal to dy dx. They are the same thing. Yes. Because that's very easy to look like. So I will show you example. So let's say if I take a derivative of 6x, 6 root x like this. I don't like the 6 because 6 confused me. So I can take a 6 outside. Now, for me, like, I don't do this step. I do it inside my head. I just kind of leave the 6 alone and I don't do anything to it. I just think about 6 is always there. Now, I can just take a derivative of this. Then can I say that's going to be x to the 1/2? So it'll be 1/2 x to the -1/2. Does that make sense? I just kind of leave the 6 out there and just take a derivative because I don't want to take a derivative with 6 in there. So I kind of like think about 6 is not there. 6 just multiply after I take a derivative of that variable to the things. So that will equal to 3x to the -1/2. That's equal to 3 over square root x. And that's my answer, or that's my answer. It doesn't matter each way. It doesn't matter. That 6 is some number that's in the front. Now, for me, like, I actually don't do that step. I just do that step in my head. So it's really easy to think about. Just don't worry about the number and just take a derivative of the variable and then multiply by the number at the end. So I'll give you something that to try. So let's say I'm going to have y equal to 5x to the third. Y is equal to 2 to the x. y is equal to 4 over 5 x squared. Y is equal to 2 root x. Y equal to 1 over 2 third root of x squared. Y equal to negative 3 over 2x. Remember that number that's in the front, you can ignore them for a little bit and just focus on the x to the whatever power. Once you take a derivative, just multiply at the end. That's my preference. I actually don't take it out, but just let you know they are separate. So I want you to take a derivative. So you want to take a derivative on first one, just write down y prime. And if you want to rewrite, you can just y prime is another way to notation that is derivative of something. Benson, what'd you get for the first one? Hurry up. Don't listen to Aiden. It's pretty easy. No, well, just don't look at a 5 right now. Just look at x cubed first. How do you take a derivative of x cubed? Okay, that's fine. So I'm gonna write down the 5 there. I'm gonna leave it alone. Remember this 3 is gonna be in the front. So it'll be times 3. X to the 3 minus 1. So that's equal to 15x squared. That's it. Okay. Next one. I will have to rewrite this before I take a derivative though. Elaine, 2 over x. What do I have to rewrite to before I take a derivative? Huh?
Would be x with the power of -2.
No. 2x to the power of -1 because this is a 1. This is a 1 that you're gonna move up to become -1. That does not make that negative. Elaine, does that make sense? There she is. Where you been? What? Yeah, because this is 1, right? So if you move, the 2 is still there. The 2 is a constant. Didn't change.
Like if it was like 2 over like x cubed.
Then there'll be 2x to the -3. So right now I didn't do calculus. Right now, after that, I'm gonna do calculus. So that 2 is in the front that I don't do anything about. And the -1, x to the -2. So it'll be -2 over x squared. Catherine, does that make sense? You got this? Good. Kaiwen? Good. Madeline? Arvin? Good. Okay. Now, do I take a derivative of this? What is the constant? Almost. 4 over 5. I'm not going to do anything. I'm going to take a derivative of the x squared. What's the derivative of the x squared? 2x. And then just going to be 8x over 5. Done. Something like this, very tiny, small, you got to be very precise about. Vincent, I'm picking on you until you get it. 2 square root of x. Can I change that x to a rational exponent? Okay. What would it be? 2x to what power? Huh? Nope. 1/2, good. Because this is a 1, this is a 2, right? This is 1/2. So guess what? Y prime is going to be 2 times 1/2. Because I'm going to break down the 1/2 in the front. X to the what? There we go. You got it. See, this cancel out. That's 1 over root x. This one here. Can I rewrite this? Alan, you gonna help me with this one? One over two. How do I change the x to the 3? X to what power? 2 third power. Okay, can I take a derivative from here? Negative what? Negative what? No, you don't change it. This one's 2 third, change it to the top. It's going to be 2 third negative. If you change sides, it becomes negative. That's it. You got it? Because this is the negative exponent rule. So a to the negative n equal to 1 over a to the n. This is going to be on your SAT. So 1 over a to the negative n equal to a n over 1. So basically, this is negative. Just switch to the top, becomes happy. If I'm sad downstairs, then I'm going to go upstairs and become happy. It's pretty much it. So like here, I'm happy here, but if I go upstairs, I become sad. Does that make sense? Yeah. So y prime is equal, and don't worry about asking a question because right now is a good time to ask a question. Now I'm going to take a derivative of this. It'll be negative 2 over third x. X to the what? Negative 5 third. So that's 2 cancel out. That's negative 1 over 3. X to the negative 5 over third. That's equal to negative 1 over 3. X is to the third root to the 5. I move the bottom first. And that's equal to negative 1 over 3. X to the third roots of 5. And that's the final answer. This is the final answer. They all fine. They all three is pretty good. It's not.
Isn't it 2 times that? Not 3? Why is it 3 times that?
3 to the third root of x to the third because this 2 cancel out. There's 1/2 in the front. You forget about that 1/2? That 1/2's always there. It's simplify. Now let's take a derivative of this one. What's the derivative of this one? This one's actually very easy. What's the derivative of negative 3 over 2x? Corbin?
You can take out the negative 3 over 2, and then would that be negative 3 over 2 times 1 times x 0?
What's x to the 0?
That would also be 1.
Yep, so it'd be negative 3 over 2, right? But here's the thing. It's not that hard. Remember, derivative is looking for slope. What is the slope of this equation? It's right here. So any x to the first power is just a number in the front. Got it? How much time I have?
40 minutes.
Okay, good. Okay, so let's say I want to take a derivative of this. Now this one, just knowing your exponent rules. And the problem is, like right now, all my pre-calculus class, I'm drilling them with exponent rules. Like I'm talking about drilling them. They have to be, by next year, those kids are gonna have like pass rate of like 100%. Because I'm start drilling them this year. Chase. Something wrong with your mind, Chase. After what you did to Anthony. Add just file.
And for the last two, that's
What do you do, Dan?
negative.
You don't want to know.
Negative
Huh?
And the bottom two, it's x to the negative 2 and not x to the negative 6.
-2, yeah. Let me rewrite that. So parenthesis rule is affecting a lot of things. So for me, like um, I actually don't think about certain things. I actually just think about, I'll always simplify something first. So if I choose to simplify, then what can I do here, Madeline? How do I take a derivative of this? Can I rewrite this before I take a derivative? Or can I take a derivative now? X to the what? Negative what? Yep, that's it. Now you can take a derivative and you can ignore that 5/2. I just write the 5/2 that's in the front and I just focus on taking derivative x to the -3. Is that okay? So it'll be what? -3 x to the what? There we go. That's equal to -15 over 2 and x to the -4, or -15 over 2x to the 4th. And that's my final answer. And if you see that I'm spending more time rewriting than actually taking derivative, and that just makes easier for me to take derivative. Remember, you don't need to use definition derivative anymore, except the next quiz, 2 questions. But after that, you can use the power rule now. You can use a shortcut now. How do I take a derivative of this? But before I take a derivative, what do I have to do? 5 over 8x cubed. It's not 2x cubed because that 3 is affecting the 2, and that's very important for you to understand. And I haven't taken a derivative yet, so I'm going to write down d to the dx. If I go ahead and take a derivative here, no, I'm not going to be able to take a derivative, so I need to do one more thing. What's one more thing? There we go. Now I can take a derivative now. So it'll be -15 over 8 x to the 4th. And look at it. There's 2 different answers. It's because of parentheses. Parentheses is the one that's gonna get you. Notice people are good at math. They understand parentheses. Parentheses is like typing math without space bars. Without space bar, you don't see anything. If you see parentheses, then you can see the essay. If you don't have a space bar, it's very hard to see the essay. I'm very, very confused. How do I take a derivative of this? Can you take a derivative of this on your own now? What's the first thing I need to do, Elaine?
That's 6 or 2.
2.
So it would be like square, right? It becomes positive.
Yep. And then what I do to take a derivative of that? What's the derivative of x squared? That's it. And that's 14x over 3, and you're done. What's the derivative of this?
Should I do it? I gotta do it really fast.
Hmm?
How come sometimes like you multiply like how come sometimes the answer is like the
Because I'll change, like it says, if it's something like this, the -4 is still on the top, I change to the bottom. Usually I prefer positive exponents. But before I take a derivative, I can do negative exponent because sometimes derivative need to be negative. And it just at the end, I have this one last step. I'll move to the positive exponent. So here I'm gonna do 7. This one's 3 to the negative 2, x to the negative 2, right? That's 7 times 3 squared now, times x to the 2. So that is 9 times 7 is what? No. 63x squared. So if I take a derivative of this, it's going to be 126x. Got it? Okay. How do I take a derivative of f of x plus minus g of x? If I take a derivative of this, basically just, hey, that's just f prime of x plus minus g prime of x. Is that okay? It's just kind of distribution. It's kind of distributing. Distribute and take a derivative of f of x plus minus take a derivative of g of x. No, but let's just say if I have y equal to 3x squared minus 4 square root x, I'm taking derivative. There's two functions. First function is 3x squared. Second function is 4 square root x.
That's not g of x.
Yeah.
You just kind of confuse me.
It just have to take a derivative of this and take a derivative of this and subtracting each other. That's it.
You do it 2 times.
Yeah. It's like kind of like you take a derivative of the first function and subtract, take a derivative of the second function. They are not distributable, but they are the rule. The rule says if you take derivative of one function plus another function, then it'll be f prime function and g prime of x. It's because you assume this is f of x is a g of x. So what is the derivative of this? Yes.
Is it 6x minus 2 over root x?
6x, that's perfect. That's derivative of 3x squared. But before that, I cannot take a derivative, right? So that's going to be x to the 1/2. Now I'm going to do 4 times 1/2 times x to the what? Then that's going to be 6x minus 2, x to the negative 1/2. Now Elaine says, why do I always move on the bottom? Because I don't like negative exponents. So I'm going to say that becomes like this.
Mr. Ray,
Yep.
how are you distributing the derivative?
You're not distributing. They just say if you take a derivative of one function plus minus another function, they just want you to take a derivative of the first function plus minus a derivative of the second function. So look kind of like distributing, but it's not distributing. It's one of the rules on derivative. It's called sum and difference rule. Are you doing okay? You need to watch a video over in the top. Are you still sick? How much time I have? Good. How do I take a derivative of this? Remember, do algebra first.
Just find the derivative of just
Drag. She's delivering drag. What is that? All right, so what kind of algebra I can do first? Can I say that's x to the 1/2 times x plus 1? can I distribute this? Does that make sense? Am I going to pass?
Where does finding the derivative fall on? What's the order?
I'll do it when it's done right. So now I'm gonna take a derivative. It's gonna be 3 over 2 x to the what? 1/2 minus 1/2 x to the negative 1/2. So that's gonna be 3 over 2 square root x minus 1 over 2 root x. And that's gonna be the derivative of this. Sometimes question gets a little bit harder. When bottom's monomial, I always say this before. On my algebra test, I have something like this, right? I have something like this, right? What do? You can what? Not factor. Break up to what? Pieces, right? Right? Do you remember this? Am I crazy? What? You missed this, right? Easy math. You can
Divided
code.
by 5 by 6.
Oh, I don't know. That's x. So that's, sorry, this is 6, right? Now if I, do you see that if I can take a derivative now, it's much easier? If I split up to individual term. So can I split up this? Did you finish your relay rate?
No.
Alright, I can hear you. Wait, no, we're looking down here, how much X you get? Yeah. Oh, okay,
Yeah.
Wait, what'd you?
okay. Okay, well, you like got an 80, I did too. I did
Yeah,
that, it
it's
should be at least
93.
93. It should be a 93.
It's arbitrary for me. Randomness.
No, he usually just bases it on right.
It's whatever you.
But if you get 100 on chest,
So now I didn't do any math yet. Did I do any calculus yet? Did I do any calculus? Madeline, what's your question? Yeah, now I can do it separately after I break them apart. So now I can say f prime of x. Now I take a derivative. A lot of people say this is derivative. That's not derivative. That's just a rule for algebra, right? So that's going to be 3 times 3 over 2 times x to the 1/2 minus 1/2 to x to the negative 1/2 plus 1/2 x to the negative 3/2. And that's going to be 9 over 2 x to the 1/2 minus 1/2 square root x. Well, this is square root x here. And plus 1/2. This one is going to be square root x third. And that's f prime of x. And I might you to build equation tangent line today, so finish. Huh? Finish your related rate. Today. Finish going over your related rate. Yes, the homework you didn't do.
Why does she get 100 on the paper? You should give her like.
Hey, I'm A in this class right now. I'm an A in the class.
Oh, I have A in this class too.
No, you don't. No, you don't.
I'll pull up my shower and out.
I'm more lenient than BC kids. When you get a BC, I'll be more lenient.
It's the beginning of the year. I did this all last year. Guys, chill. Related grades was not my era last year, guys. Chill.
Thanks for letting me know. Hi.
Banana bread?
Banana bread?
He made it this morning.
Thank you.
Of course. I would give more, but Irby ate most of it.
That's okay. I'm gonna finish Giovanna's thing first. Somebody asked me on the group chat, who's this guy? Hazar? Hi, Hazar. Do you still have a question? Hi.
I just need to take this.
Miss A.
I don't know. I feel like I know the material. I think I just get like stressed like checking over my work and like actually making sure that it's right. But I felt pretty okay about it.
Calm down. It's okay.
Thank you.
You got this. Okay, you guys cannot be loud. Oh, you got to go after from me.
Don't play with this. Because I'm dehydrated.
Harper, smell your words.
Are you think, bro? I don't think I have time to sit there and wait for your freaking order. I'm gonna walk all the way back.
Are those ice or is it what? For the second?
Cats.
I'm doing the opposite.
CAT.
Yeah. I think I got it. It's a little weird.
Bro, what are we even doing with this right now? I don't know.
Min, keep it low because she's taking tests.
I got it again.
Rajosh, keep it low. Amanda, you finish? Okay. Can I see it? Well, after you finish both, I'll see it. Try to finish the second one. Nathan,
Yes.
you cannot be loud. Somebody's taking the test. The fastest way is to get rid of fraction at the same time. So you multiply both sides by CAT because CAT are the least common denominator. Multiply everything by CAT, and then you're gonna see all this denominator end up canceling out. What do you have right now? B, so you don't get in trouble. But it will go up. I believe in you. So today you say I don't know. What to say. Shoot. I
On question one.
still on question one.
I just got here.
Oh my god, you're supposed to do that yesterday. It's yesterday's homework.
What? Oh,
I suppose
I guess-
yesterday.
I guess yes, but the point is, isn't this just 400 kilometers per hour? Because I mean, unless the radio station's on the ground, I guess
The radio station is on.
Okay. that makes more sense.
It's
I was
flying
thinking
above
that-
the air.
I
It's
was
like
thinking
this.
The radio station was like at equal height.
How do you build a radio station on top of the sky? Nathan,
I'm all over the place.
okay, you cannot cannot build a radar station. I mean, you probably could in the future technology.